Okay, in this video we're going to learn how to take the data out of rocket.txt. We're going to take the time and position data and we're going to learn how to transform it into a set of velocities. And then we're going to write to a new text file not only the ordered pairs, which is time and height, or time and position, but we're also going to write out the ordered pairs time and velocity. And then we'll be able to graph the data one against the other and cause what the goal of this video is to create a link now between what we're learning in computer science and what we're also learning in calculus. So okay, here we go. First thing I need to do, I basically only need two basic imports, the scanner class and the input-output class. So first thing I want to do is I want to make my user type in the name of the file that I need to open, which by this time in your email you should have received rocket.txt. Make sure that rocket.txt is in the same folder with rocketvelocity.java. That's going to be important. So I read the file name in, I create the file, and then I want the name of the output file. Where should I be writing all of the velocities? So I read in the name of the output file, and then I close my reader on line 21. So far, so good. Now I have to begin to create my writer object so that I can write my velocities to the correct file. So on line 24, I create a print or a writer object, a print writer object named writer, using the output file that I just typed in and creating a new print writer. Now what's important on line 28 is I need to keep a record of how many ordered pairs are in my file, because I'm going to have to store all of that data into arrays, and I'm going to have something along the lines of 1,202 ordered pairs to work with. So this file could have any length, okay? So I'm going to initialize number of lines to 0, and I'm going to keep track of how many lines my text file has. So now I'm going to, on line 32, I'm going to create a string variable called input, and I'm going to set it equal to empty. I'm going to glue all my ordered pairs together into one really long string, and the values of the ordered pairs are going to be separated by spaces. I think this is the best way to handle the data. Let me show you what I mean by that real quick. So I'm going to go ahead, I'm going to open up rocket.txt. There it is. Okay, what do I mean by that? Well, the first line is 0.0 comma, or not comma, but space 10.0. The second line is 0.01 space 10.87. What I'm going to end up doing is I'm going to end up taking all of these ordered pairs on these lines, and I'm going to be creating one long string that's stored into input. So it'll look like this: 0.0 space 10.0 space 0.01 space 10.87 space 0.02 space 11.74, and so on and so on and so forth. It's going to create one really long string which is going to have twice as many data values in it as there are ordered pairs. I think this is the best way to manage it. And then what I'm going to do is I'm going to break that string apart using the split method. I'm going to show you how that works. So first I create this as empty. Now, while file has next, while there's something to read, begin the gluing process. Input plus equals file.nextLine, and then add in a new space at the end. I have to do that because when I read this line, it's going to read 0.0 space 10.0, but there's going to be no space here after 10.0. So I have to add in this new space for the next ordered pair. Update number of lines. Now, if in the situation that my number of lines was less than or equal to 1, that meant I either had no ordered pairs or I only had one ordered pair, and you can't calculate the velocity based on one ordered pair. So if number of lines is less than or equal to 1, print out no data is in the file or only one ordered pair found, terminating program. and then use the exit message part of the system class, and it will terminate the whole program. Now that I know the number of lines, I can create my arrays. Here's my time value array. Here's my position value array of the rocket. And here's the velocity values array that I'm creating. Notice that the size of velocities is one less than the total number of ordered pairs that I have. And there's a reason for that. If I have 10 ordered pairs, I can only at most create 9 velocities, because velocities are created from 2 ordered pairs. So the number of elements you'll have in your velocity array will be one less than the number of elements you'll have in your time and your position arrays. Now I'm going to create an array of strings called input list, and that's going to take this one really long string and it's going to split it up using the space as the delimiter. So now it'll be an array which will look like this. 0, 0, then the next element. Let me write it out first so you can see it. Input list 0 will equal to 0.0. Input list 1 will equal to 10.0. Input list 2 will equal to 0.01. Input list 3 will equal to 10.87, and so on and so on and so forth. So that's what I'm going to do now to create my input list. Now what I'm going to do is I'm going to start converting these strings into actual numbers in their respective arrays. So for I equals 0, where I is less than number of lines, increment I, I've got to remember that the t value is the first part of the ordered pair, and the position value, the s, is the second part of the ordered pair, which is why these are so different right here. This is 2 times I, this is 2 times I plus 1. So if you start I at 0, 2 times 0 is 0, 2 times 0 plus 1 is 1. So it'll read in the 0 element of input list, store it into the first element of t. It'll read the second element, which is index 1 of input list, which is the position of the first ordered pair, store it into S0. So this will create all of my t values and my s values. Now I calculate the velocities. So on this line, this is simply si plus 1 minus si, all over ti plus 1 minus ti. And this is exactly the same thing as in algebra when we had y2 minus y1 over x2 minus x1. The only difference here is that we're dealing with t and s, and we're also dealing with arrays, so the index is based upon I, not upon anything else. What am I doing on line 69? Well, I'm guaranteeing that what I have has only 2 decimal places of accuracy. So what I do first is I take my velocity value and I multiply by 100, which shifts the decimal 2 spaces to the right, and then I cast that to an integer, so it's going to drop any extra decimal places. Then I divide by 100.0, which is mixed mode arithmetic, and it will convert it back to a double. And so that will guarantee that I only have 2 decimal places of accuracy. So if I wanted 3 decimal places of accuracy, I'd change the 100 to 1,000. And that's how it would work. Now I'm going to start writing things to the file. My very first ordered pair in my rocket.txt file is not going to have a velocity, because remember, it takes 2 ordered pairs to create a velocity. So the first velocity that I record will actually be for the ordered pair 0.01, comma 10.87. So if I is equal to 0, I'm just going to write the time and the position and then create a new line. Otherwise, I write the time, space, position, space, time, space, velocity value, and then I add in a new line. Then I close my writer when it's all said and done, and then I let the user know that the data has been written, what the name of the file is, and then the program is terminated. So when it's all said and done, your file, I called it Rocket Velocities, should look like this. And now we'll be able to graph our data in a spreadsheet, and we'll be able to see how the time versus position curve relates to the time versus velocity curve. Okay, now you can go back through this video and pause at certain points so that you can get this typed in. But the goal of this video is to show you how what we're learning in computer science can tie in to what we're learning in AP Calculus, because now we're talking about instantaneous rates of change. All right, God bless you, wherever you are today.